Welcome to the third video in this series, which is designed to help you with your Microeconomics for Business module. In this video, we will be looking at graphing functions. During the video, we will look at concepts such as the coordinate system and how to plot points. What are the x and y intercepts and why are they important? Then we're gonna go into details on how to plot linear graphs. We look at the gradient or the slope, which is a very important concept. Then we look at a specific way of writing linear equations algebraically, which is called the gradient intercept form. Then we go into details on how to plot more than one graph. We will also look at how the supply and demand shifts and why do we call them right or left shifts. And in the last part of the video, we will be looking at how to read information off from graphs. Now, before we go into exact practical examples, I would like to recap some of the notations. So, for example, if you see y equals f of x, that is just basically telling you that the y coordinate is the image of the x coordinate through this function of f. In this particular case, we don't know the specific function, so I will need to be giving a function to be able to calculate these two things. But again, just remember that y equals f of x just means that the y coordinate is the image of the x coordinate that is created by the f function. One more important thing is that the order is very, very important. So if you were given coordinates, or sometimes we also call them ordered pairs, the name gives it away, the first number will always be the x coordinate and the second number always will be the y coordinate. And these are just individual points on the graph. For example, I can give you 3, 4. So for this particular point, the x coordinate is 3 and the y coordinate is 4. Or I can give you something like -2, 7. So the x coordinate in this case would be -2 and the y coordinate would be +7. When we draw a coordinate system, we start with a number line. This number line has a 0 and it has got some kind of scale to it. Now, the importance about this scale is that every equal distances, physically equal distances, have to represent equal number distances. So if I decide that this will be 1, then this have to be 2, because the distance, the physical distance between these two are equal, so the numerical distance have to be equal too. And then I'm going to have to go both ways. Now, these physical distances are my choice. Obviously, if I wanted to talk about years, this would be suitable. But if I wanted to talk about decades, again, I could make them into 10, 20, 30. Or if I wanted to talk about money, for example, I could make it 1,000, 2,000, 3,000 instead of just 1, 2, and 3. And again, if I wanted to, I can decide going up in 1s and 10s are not good enough, so I can go up in 5s. Depends on the data that you need to draw. So depending on what kind of information you are given that you want to represent graphically, the scale can be chosen accordingly. So that will be our x-axis or the horizontal axis. And obviously, in practical examples like price and quantity, we're not going to name it x, we probably name it something else, either price or quantity. So that is just the horizontal axis, so it's not a coordinate system yet, it's just a number line. So how are we making it into a coordinate system? So basically, we're going to pick up another number line, rotate it 90 degrees, and then place it down here exactly the way that the zeros line up. So this now would be 0 on the x-axis, which is the horizontal axis, and 0 on the other axis, which we're going to call y-axis or vertical axis. Again, same goes for the scaling. So equal distances have to represent equal numerical distances. And then obviously I can go down into the negative direction as well. Now, in practical examples, again, when I decide to talk about a certain, let's say, GDP change over time, I need to make sure that the audience who's going to read my graph will be clear about what is this graph. So I'm going to have to give it a title. So I can say GDP change over time, or I can be more precise, GDP change between 1900 to 2000. Again, depends on the situation, but also I need to make sure that the axes are appropriately named. So in this particular case, I wouldn't use the y-axis anymore. What I would use is GDP here, but I would also need to give, what am I talking about? GDP. Is it thousands of pounds? Is it millions of pounds? Is it billions of pounds? Depending on the country, obviously, but usually millions and pounds or euro even would do. And therefore, obviously, on the other side, it's not X anymore, but time. And again, I need to make sure that I'm measuring it in an appropriate scale, because obviously between 1900 and 2000 there is a good 100 years. So I'm definitely not going to have enough space for every single one of those 100 years. So I might want to go up in tens of years, I might want to go up in 15s of years, something that's suitable, but one probably would not be the most suitable. So if I know a coordinate, let's go back to these simple examples. How can I plot these points? Now, this is your starting point, which is very often called the origin, and this is always the 0, 0 coordinate. Obviously, that's how we created the system. We matched up the 0 on the x-axis and the 0 on the y-axis. And the other thing that you need to remember is that the first point is the x coordinate. That is telling you how far in the x direction you went from the origin. So because that's 3, I went 3 directions in the origin. So this is 1 coordinate. The other one is 4. That is the y coordinate. So that's telling you how far you went in the y direction from the origin. So you went 1, 2, 3, 4. That's the other one. So where is this 3, 4 point? Well, it's basically exactly in the intersection of these two distances. So it's exactly here. So when you come up to the x-axis, just draw a line parallel to the y-axis up. And when you come to the y point, just draw a parallel line across with the x. And where the two intersects, that's exactly where the point is. Look at another example. So I've got -2 and 7. Now the negative means that I'm going into the negative direction. So I'm going to go -2. So that's the x. And then I'm going up 7. So I'm going to have to be a little bit creative here. That would be roughly there. So I could go up here and obviously coming across. So this would be the -2, 7 point. Now, how can we do it the other way around? So how can we read off coordinates of points given the position of the points? So we've got 3 points here, A, B, and C. What are the coordinates? Well, to find the x coordinate, all I need to do is trace down to the x-axis. That's hit 2 exactly. So the x coordinate is 2. And to find the y coordinate, I just need to trace across until I hit the y-axis, So this point's coordinate is 2, 4. How about B? So I'm going to come down and I'm going to come across. So B is -1, +2. And same goes for C. Go for the x-axis and then go for the y-axis. So that gives me 2, -3. Now this is the exact full coordinate system, which has got 4 quarters. This is quarter 1, this is quarter 2, this is quarter 3, and this is quarter 4. Now, what are the important properties of these quarters? Well, if I look at the x-axis, this is on the positive side of the x-axis, but this is also the positive side of the y-axis. So the first coordinate, both of them, the x and the y, are positives. In the second quarter, when I look at on the x-axis, I am on the negative side, but the y-axis is still on the positive side. So it would be the negative positive quarter. If I come down to the third, when I look at the x, I am on the negative side, and when I look at the y, I am also on the negative side. So it's the quarter where both of the coordinates are always negative. And in the last one, x, I came back onto the positive end, but with y, I'm still down on the negative end. So this is the positive negative quarter. Now, in many cases, especially in economics, you are not going to use the full coordinate system. In most cases, you're just going to use the first quarter because you only need prices and no quantity can be negative and no price can be negative. So in many practical applications, you don't even draw these 3 quarters. But again, just be aware that you can go down on the negative direction in each cases. Because, for example, if you would be looking at profit, net profit can go negative. Prices can't, but profit can.